Viewers, you're welcome to Science Spectrum with Dawn. This is Chemistry 189, the fundamentals, and this is the second part of the first lecture in Introduction to Chemistry. Alright, now from the previous class, we talked about the history of chemistry, how the art of chemistry was studied empirically by the Egyptians civilization down to the Greeks, to the Phoenicians, and of course down to when modern science was born. And of course we talked about how scientific knowledge was gained. And we discussed about the facts briefly that scientific knowledge was gained through serendipity. Serendipity, which is simply the trial and error method. Trial and error method. Just an empirical way of discovering things. And of course the second way we gain knowledge scientifically is by what we call the scientific approach. By the scientific approach or the scientific method. Scientific approach. Alright, so we're still in serendipity. Of course, I talked about a college boy by the name William Perkins, who in 1856 discovered dye, and that brought about the dye industry. And of course he did this just by trial and error method. I discussed about that from the previous class. He was about synthesizing a malarial drug by the name quinine, and he reacted aniline sulfate with potassium dichromate, which he extracted with alcohol. And of course due to the volatile nature of the alcohol, as it evaporated, a violet crystal was left, which when dissolved in water, brought about this beautiful purple color, that birthed the mauve dye, industry. This is William Perkins. We also have James Schlatter. James Schlatter happened to be a researcher, 1965. He happened to be a researcher in a renowned pharmaceutical firm by the name GD Seal. He was researching for anti-ulcer drug, and empirically he tasted what he had mixed and discovered it was sweet, and that birthed a sweetener by the name aspartame. Aspartame happened to be an artificial sweetener. So what's aspartame? Is simply two amino acids joined together. Alright, we also have a discovery by serendipity made by let's see, this is we have also Barnett Rosenberg actually discovered cisplatin. He discovered, this is in 1964, he discovered cisplatin. Cisplatin happened to be an anti-ulcer drug. And how did he achieve this? He got a bacterial culture and saw the effects of driving an electric current through two electrodes that were made of platinum, and he discovered that the growth of that bacteria was being inhibited as current was driven through the two electrodes. And of course that birthed this product, cisplatin. You hear of carboplatin, you also hear of other platin products. These are actually anti-cancer products. Now the list will go on and on. You hear of Alexander Fleming, who discovered an antibiotic by the name penicillin. You hear of the discovery made by Fallberg and M. Ramsey, right? And what they actually discovered was saccharin, an artificial sweetener. We talk about cyclamate also, that was discovered by M. Zveda. And of course the list could just go on and on like that. Now I would talk about the second way we gain scientific knowledge, which is by the scientific approach, or at times we use the word scientific method. All right, so let me talk briefly about the scientific method. So the scientific method is simply an approach by which we solve, problems, or we carry out, or we seek for solutions to tasks, we encounter in our everyday life. And of course, we could relate this, to how we solve problems in chemistry. So the first scientific approach is simply to make observations. We make observations, and observation entails, it could be a qualitative one or a quantitative observation. Qualitative in the sense means we could make notes, and describe, the process, that happens around us. And we could also, associate unit values, or we could measure, properties of what was really observed. So that's the first one. Then, when we analyze what we have observed, which could be either by the qualitative or the quantitative way, we may want to explain, we may want to try to explain, what we've observed. So that explanation of what we've observed, we call that hypothesis. So we hypothesize, hypothesis. What is simply hypothesis? It is simply a tentative statement, right, about natural phenomena. So tentative there means it is subject to change. It's just your own way of profiling possible solutions, to problems. And this hypothesis could be tested, right? It could be tested, through or by experiment. What is an experiment? It is simply a highly controlled procedures, highly controlled procedure that could trigger observations, that may either confirm or refute a hypothesis. So an experiment, is also carried out, right, that would generate an observation that could either confirm or refute a hypothesis. And of course, when the experiment is consistent with the hypothesis, right? So we say in that case it becomes a well-established hypothesis. We could call that a theory. So a theory is simply a model, just a model, that gives an interesting insight into how and why nature behaves the way it does. And of course, there are times, now even this theory itself, right, is not really the final point, but though we could say it is the peak of the scientific approach. Now, this theory, at times, might be changed based on the fact that, further experiments, may be carried out, and when they are carried out, it may prove this model either true or false. And when we make observations, at times we discover a series of similar observations, different persons, observing the same thing and, generalizing what has been observed. In that case, we call that a scientific law. We call that a scientific law, or we use the word principle. We use the word law or principle. So this is just, a brief approach, a brief step to the scientific approach. It starts off with observation, right? You analyze what has been observed, either quantitatively or qualitatively, and that would birth an explanation that could be, that is subject to change, which we call a hypothesis. So this is just an explanation called a hypothesis. And of course, we could test for the hypothesis, for it to be either confirmed or refuted by an experiment. What an experiment is simply a highly controlled procedure that generates observations that would either confirm or refute that would either confirm or refute a hypothesis. So an experiment itself is subject to observations because the goal is it may either confirm or refute the hypothesis. And of course, when the experiment is consistent with the hypothesis, that's what has been said, it becomes a theory. A theory is just a model, a picture, that explains how and why nature behaves the way it does. And of course, a theory could be proven wrong with time. It's not, the ultimate truth. And it could be proven wrong by experiments, which is also subject to, observations. And there are times we come across series of observations that are similar. In that case, we generalize something about natural phenomena. In that case, we call that a scientific law or principle. All right, now I may need to define to us chemistry. So chemistry has a precise definition. So we'll talk about the definition. This marker is a little bit faint. We'll talk about the definition of chemistry, and consequently, we would also see, the job functions of chemists. So definition of chemistry. So make no mistake about it. Chemistry is a part of pure science, right? Which is a division of philosophy, which was birthed by the Egyptians. The Egyptians fathered philosophy and medicine in 3000 BC, that's about 5,000 years ago, way before the Greeks. All right, so chemistry could be defined as a fundamental branch of knowledge. It's a fundamental branch of knowledge. Why? It's a part of pure science. It's a fundamental branch of knowledge. It is the pure sciences, right? They are intertwined. So it's a fundamental branch of knowledge that seeks to understand, the behavior or the properties of matter. We call behavior the properties of matter by studying atomic and molecular systems. All right. Now let me just break this down further to us. The behavior of matter is uniquely determined by the properties of their atoms and the molecules. So, I need to write this down. The way matter behaves, is uniquely specified by its atom, or the molecules or the ions, that constitutes matter. So we say matter, the behavior of matter is determined by the properties of their elementary entities. And what are these entities? It could be atoms, or molecules, or ions. These are the building blocks of matter. All right, I need to wrap it up here for the sake of time. And if you're new to the channel, you may want to like, share, and subscribe for more content. Thank you.